Hello, fellow cosmic enthusiasts. Today, we're diving into the captivating journey of our very own celestial powerhouse, the Sun. From its birth 4.5 billion years ago to its future transformations, we'll explore the fascinating life cycle of this radiant star. Buckle up for a cosmic adventure as we unravel the mysteries of the Sun's evolution. 1. The Sun is the closest star to the Earth. The Sun, a colossal ball of plasma, serves as the stage for thermonuclear reactions within. Positioned approximately 150 million kilometers away from Earth, our star is a typical G-class celestial body in the midst of its life cycle. Boasting a surface temperature of 5,506 degrees Celsius or 9,942 degrees Fahrenheit, the Sun emits nearly white radiation due to this extreme heat, with its rays taking on a yellowish hue when filtered through Earth's atmosphere. Across the vast expanse of the universe, the distribution of stars of varying sizes is not uniform. Consequently, the Sun surpasses more than 90% of its stellar neighbors in size within its specific region. Furthermore, it acts as a crucial reference point for us, providing insights into the nature of similar celestial entities as we observe and study its characteristics. 2. The element helium got its name from the Sun. In the initial attempts to decipher the chemical makeup of our Sun through its spectrum, scientists identified lines of radiation corresponding to an unfamiliar element. Initially thought to be exclusive to the Sun, this element was named after the Greek god of the sun, Helios. Although this substance was subsequently discovered on Earth, the name persisted. Approximately a quarter of the Sun is composed of helium, with another 73% being hydrogen, while the remaining portion consists of heavier elements. The energy produced by our star results from the thermonuclear reaction that transforms hydrogen into helium. 3. The mass of the Sun is 500 times greater than that of all the planets around it. The Sun constitutes a staggering 99.866% of the total mass of the solar system, surpassing the combined weight of all planets and asteroids by a factor of about 500. Remarkably, even Jupiter, the largest planet, is merely 1,000th of the Sun's mass. In comparison, the Earth is significantly lighter, weighing approximately 333,000 times less than the Sun. The sheer enormity of our star becomes evident as it could accommodate a whopping 1.3 million Earth-sized planets within its voluminous mass. Additionally, the Sun boasts a density approximately 40% higher than that of water. 4. The Sun has a crown. The solar corona, derived from the Latin word for crown, represents the outer layer of our star. Comprising prominences and diverse plasma eruptions, these structures often extend hundreds of thousands of kilometers, surpassing the distance from Earth to the Moon. Remarkably, the solar corona ranks among the hottest regions in our solar system, with an average temperature ranging between 1 to 2 million degrees Celsius or 1.8 to 3.6 million degrees Fahrenheit. In certain areas, its temperature can spike even higher, reaching up to 20 million degrees Celsius, around 36 million degrees Fahrenheit. The solar corona becomes visible from Earth during a total eclipse, providing a captivating spectacle when observing our luminary. 5. There are spots on the Sun. The Sun's surface layer responsible for emitting visible light is termed the photosphere. Within this layer, colder regions appear darker. Observing our star through a telescope directly is challenging, but with the use of dark filters, large clusters of sunspots become visible. Sunspots are regions on the solar surface where the magnetic field lines are twisted and torn. This magnetic activity gives rise to potent plasma emissions known as solar flares. To investigate these phenomena, the Solar Orbiter device was launched. 6. Solar wind can cause magnetic storms on Earth. The magnetic field of the Sun continually propels charged particles known as the solar wind. Typically, its strength is insufficient to pose any threat to individuals on Earth. However, during solar flares, a substantial quantity of charged particles may be released, and occasionally, a sizable section of plasma can detach from our star, a phenomenon known as coronal ejection. Upon reaching our planet, these particles or plasma interact with its magnetic field and atmosphere, resulting in a magnetic storm. This event can manifest as auroras borealis and has the potential to disrupt electrical and radio equipment, as well as adversely affect individuals with chronic health conditions. 7. The activity of the Sun changes periodically. Solar flares manifest in a seemingly chaotic manner, making it unpredictable when any of the current spots on the solar surface will erupt. There may be underlying mechanisms at play that are not yet fully comprehended. Despite the seemingly irregular occurrences, the overall number of spots adheres to a specific rhythm. These follow regular 11-year cycles, encompassing both a maximum and a minimum. The ongoing cycle, now the 25th since the commencement of solar observations, anticipates its next activity peak in 2025. The cause of this periodicity remains unknown, and scientists are uncertain whether the duration of these fluctuations undergoes changes over time. 8. Complete solar eclipses will not take place forever. A solar eclipse transpires when the moon positions itself between the Earth and the Sun, causing either complete or partial obscuration of the luminary for a specific region on our planet. Due to the inclination of the moon's orbit relative to the plane of the ecliptic, these events don't occur at regular intervals of the 29 to 30-day lunar phases, but rather 2 to 5 times a year. A total solar eclipse happens when the moon entirely obscures the sun, while partial and annular eclipses present variations. Annular eclipses occur when the moon, positioned in the farther part of its orbit, appears too small to completely cover the sun. Looking ahead, approximately 600 million years from now, total solar eclipses are anticipated to cease. As the moon gradually moves away from Earth, reaching a distance where it consistently appears smaller than the sun, only partial and annular eclipses will be observable. 9. In summer, the Earth is farther from the sun than in winter. The Earth follows an elliptical orbit as it revolves around the sun, resulting in varying distances throughout the year. However, the shifting of seasons, between winter and summer, is unrelated to this phenomenon, but is instead influenced by the axial tilt in relation to the ecliptic. Consequently, when summer arrives in the northern hemisphere, it is winter in the southern hemisphere, and vice versa. Interestingly, the Earth reaches its perihelion, the closest point to the sun in its orbit, in January, coinciding with the middle of winter in the northern hemisphere. Conversely, it reaches its aphelion, the farthest point, during the northern summer. 10. The sun emits not only visible light. However, our eyes can only perceive a limited range, spanning from 380 nanometers, purple, to 740 nanometers, red. As we extend beyond this range, we encounter infrared radiation and eventually radio waves. On the other end of the spectrum, as wavelengths decrease, ultraviolet light becomes prominent, with most of it being filtered out by the atmosphere. The remaining ultraviolet light contributes to tanning effects. Following this, X-rays and, eventually, gamma radiation emerge. The sun emits these frequencies with varying intensities, and surprisingly, exploring parts of the spectral range beyond visible light provides us with more insights into our star. As a result, many space and terrestrial devices designed to observe the sun operate beyond the colors perceptible to the human eye. 11. The sun's radiation is growing. The radiant intensity of our sun is experiencing a gradual increase. At its birth 4.5 billion years ago, it was approximately 25% dimmer than its current luminosity. Over the course of time, the sun's brightness has steadily grown. Presently, our understanding is insufficient to determine the impact of these changes on the greenhouse effect. There is a possibility that, in 1 billion years, life on Earth could face challenges due to the escalating luminosity of the sun. Alternatively, some studies suggest that this scenario might unfold in 3.5 billion years. 12. The sun will become a red giant. Around the age of 10.9 billion years, the sun's core will commence its depletion of hydrogen. This process will lead to the sun expanding, transforming into a subgiant, characterized by an orange hue and a radius 2.3 times larger than its current size within a few hundred million years. Upon reaching 12.2 billion years, a thermonuclear reaction will initiate in the sun's outer layers, causing further expansion. The sun will evolve into a red giant, potentially engulfing the inner planets. This series of transformations will culminate in the outer layers of the red giant dispersing into space, while the inner layers contract into the state of a white dwarf. Thank you for joining us on this celestial exploration. If you found the journey through the sun's life cycle as intriguing as we did, don't forget to smash that like button, share this video with your fellow stargazers, and hit subscribe for more cosmic wonders. What other astronomical topics would you like us to uncover next? Drop your suggestions in the comments below. Until our next cosmic rendezvous, stay curious and keep exploring the wonders of the universe.